This video is intended for intermediate algebra students learning to solve complicated equations by rewriting the equation. Please follow along through this video and take good Cornell notes. So the essential question that we are going to address is, how can I solve a complicated equation? Many students would agree that equations that have decimals in it tend to complicate things. So what we're going to do is figure out, how can I rewrite the equation so that if it already has decimals, it doesn't have to have decimals throughout the entire equation. So the first thing that we're going to do is, if the decimal that you're working with ends in the following, what number should you multiply by? If your decimal ends in 0.5, you should multiply the entire equation by 2. If it ends in 1/3 or 2/3, or 0.3 repeating, 0.6 repeating, you should multiply the entire equation by 3. If it ends in 0.25, you should multiply the entire equation by 4. And then if it ends in 0.2, 0.4, 0.6, or 0.8, you should multiply the entire equation by 5. Let's take a look at an example. Now in this example, you can see that I have 12/10, a half, and 0.2. So this equation has multiple decimals that aren't the same ending. So maybe the best way to get to complete this equation is to simply just go ahead and multiply the entire equation by a number that would move the decimal place over to the right 2 units, so that way I have no decimals in everything. And the number that would do that is simply 100. So if I multiply the entire equation by 100, distribute that 100 to all of the values within this equation, here's what it would look like. Here's what the equation would look like after I distributed that 100 to the 1200ths, the 7.5, the 2/10ths, and the 3. Now this is a much easier equation to look at. I'm not concerned about the decimal values anymore, but my answer is still going to be the same as if I didn't multiply the entire equation by 100 and I worked with the decimals. So let's go ahead and let's finish solving this equation. So you can see that my first step was to go ahead and subtract 12x from both sides and then simplify the equation, followed by subtracting 300 because I want to get my x's all by itself. And then my last step was to go ahead and divide by 8, with the resulting answer of x equals 56 and 25/100ths. Another complicated equation is one that has extremely large integers. And sometimes it's easy if we can just go ahead and look for that GCF like we did when we were factoring. Let's go ahead and take a look at an example. In this equation, I have 3,000x plus 2,000 equals negative 10,000. And right away, I hope that you can see too that the GCF would be 1,000. So what we're going to go ahead and do is we're going to get rid of that by dividing all of our integers by 1,000. Again, by getting rid of that GCF, it makes this equation way easier to solve, giving us the same answer as if we were to work with those large integers. So let's go ahead and finish solving this equation. So you can see that my first step was to subtract 2 from both sides, resulting in a negative 12. And then lastly, to go ahead and divide both sides by 3 to give me an answer of x equals negative 4. Let's go ahead and look at another complicated equation. So another form of complicated equations are ones that are exponential. And so an example of this is to just simply rewrite the problem as exponents with the same base. Let me tell you what I'm talking about. So let's say I have 4 to the x power equals 16. Well, what I can do is I can take 16 and I can rewrite it so it has the same base. 16 is the same thing as 4 squared. And that's what we're going to work on. So here's our first example. We have 4 to the 4th equals 16 to the x power. And what we want to do again is to really think about rewriting it with the same base. So we're going to leave 4 to the 4th alone, and then we're going to simply use that last example that I just showed you, rewriting 16 as a base of 4. Well, 16 is the same thing as 4 squared, but we cannot forget the x. And since they have the same base, which is the 4, there is a property that you'll learn in Algebra 2 that allows us to take the exponents, which is 4, and the 2x, set them equal to each other, and just solve for x. So we're going to go ahead and divide both sides by 2, and we have 2 equaling x. So let's look at another example of this with exponents. Here we have 3 to the 2x plus 1 power equaling 27. So 3 is the base, and that's as low as what we can get. So let's really focus in on 27. How can we rewrite that with a base of 3? And actually, 3 to the 3rd power equals 27. So we're just going to go ahead and rewrite that as 3, 2x plus 1. Equals 3 to the 3rd power. And now that they have the same base, remember there's that property you're going to learn in Algebra 2 that allows us to take the exponents and set them equal to each other. So we're going to take 2x plus 1 and we're going to set that equal to 3. And now it's a much easier equation to solve. Let's go ahead and finish solving this equation. So hopefully you ended up with x equaling 1 and you have completed all of your Cornell notes. Now let's go ahead and grab that worksheet, which we can practice rewriting a bunch of different equations. This worksheet will be due tomorrow in class. Thank you. Have a great day.